What we're going to learn today is how we can calculate unknown angles within right-angled triangles, given that we know a single non-right-angled angle and another side length. Or a more succinct way to put it is, if we know that's a right-angled triangle, we know it has another known angle and one of the side lengths is given to us. If we know that, we know every characteristic about that triangle. We know the other two sides, and we could even figure out the other angle that's unknown within the triangle. Now, if we look back to what we studied last lesson, we recalled that there was a mnemonic that we say to remember our trig. Does anyone remember it? It starts with S. So, ka. And that last sound you made, but with a T at the front. Ah. So ka toa. So ka toa. You need to memorize this mnemonic and take it with you everywhere you go, even if you go on holidays, because you will use this all the way until you finish year 12 if you stay to year 12. If you go off and get some sort of trade, they'll probably expect you to use trig as well at some point. And if all else fails, suppose you are a parent in the future, you'll use it trying to teach your little one how to do this. Or if you're an auntie or uncle or anything else, you'll probably teach them how to do that because you'll be the math brain in your family. All right, so what this means is that we have three ratios. First one is sin theta, and that is equivalent to the opposite side divided by the hypotenuse. The ka stands for cos of theta, and that's equal to the adjacent side divided by the hypotenuse. And then the final one is the tan of theta, and that's equal to the opposite side divided by the adjacent. There's even more interesting things about that, but that's for another day. Now, using these three ratios, guys, we are able to determine unknown side lengths within a triangle. Now, what we're first going to do is find the unknown in a right-angled triangle. That's fun. Shh, shh. Don't even. Find the unknown, and we have A. Now, a random triangle suddenly appeared. It was characterized by its fairly standard right angle in the corner here. Ladies, I invite you to open your books and write this down. Wonderful. Claire? The angle in the corner over here was approximately 35 degrees. And lucky for us, we have a known side. The known side that we're looking at is this one over here. How big does this one look to you, Posey? If you had to guess, how many numbers is it? 11. I was thinking that exact same figure as well. And what were the units, Chanel? Kilometers. This side length here was 11 kilometers, and lucky for us, we wanted to calculate x over here. We want to know how tall this triangle is. Now, is there some sort of mathematical tool that would allow us to know all quantities within a triangle? If it's right angled, we know at least one side length, and we know at least one angle. Is there some sort of branch of mathematics we could employ here? Maybe starting with T. Trigonometry. Yes. Using trigonometry, guys, we are able to determine this side length over here. Now, because we're about to jump into trig, what we're going to do is we're going to label our triangle. First thing I do is I identify it as being a right-angled triangle, and I hence identify the hypotenuse. I label that H. Next, I'm about to jump into the angle stuff. I notice that this is my angle of interest. I label it theta. And then opposite the angle theta, This side is called the opposite, denoted with the capital O. And then there's a final one over here, A. It hasn't any markings on it. It's neither, well, it's unknown side length, but it's also not cared about because it doesn't even have an unknown symbol on it. It just is. So you have a choice. Whenever you're in this sort of position here, you can choose to just ignore the A. Now, next step. This is going a little bit further than what we did last lesson. We state all of the known values we have. We always start off with theta. So I go theta equals 35 degrees. After that, I go down the list and I'm like, I want O. So I write O is. In this case, O is X. I then go for A, but notice there is no A. So what I'm going to do is leave it out. And finally, I go for H. H in this case is 11 kilometers. And what this does is it sets us up to do the next decision, which is picking the correct ratio. When we turn our attention to the ratios, we look at the mnemonic and we think to ourselves, what mnemonic best fits the quantities we have over here? Now, because we have an angle, all of these mnemonics are currently possible. Next thing we look at is we've got O. So what I'm going to do is I'm going to look at all the mnemonics that feature an O. There, and there. And then the final one, I look at the H. I look at every mnemonic with an H. This one, not that one. And the ratio that I pick is the mnemonic that's got everything underlined in it. If we look at this, Harry, which mnemonic has each letter underlined? Yeah, this one. So Harry says this one's the winner. Harry says this one is the winner. So what we're going to do is we're going to employ this ratio to find the unknown value for X. Next thing I do is I get the ratio and I write it out. It's going to be, we'll say we're using so it's going to be, and I'll move over to this side, just for space.
I think you dropped it.
I think I might have. Sin theta equals opposite over hypotenuse. I always restate the ratio. Next thing is I go for substitution. Every time I see theta, I write the angle. In this case, our angle is 35. The opposite is x, and the hypotenuse is 11. Now we've got one of these trig equations here. And the question is, well, what do we do? Well, what we have to do is we have to rearrange it in terms of x. First thing you see is that x is hanging out with a number on the bottom. In this case, 11 is dividing x. How do I reverse division? I multiply. So I get both sides and I multiply by 11. Welcome, Jade. After that, the 11 and the 11 cancel, so I get x on the right, and then I have 11 sine 35 degrees. Now, what side is x on? The wrong side. I'd also accept the right side. What do we do if x is on the wrong side? Well, we flip everything about that equal sign. So I just reverse. This is going to have the effect of x is on the left, 11 sine 35 degrees is on the right. And it's at this point where you are allowed to reach forward for our calculators. Hands up if you need a calculator. You'll need a calculator to calculate this. Another way to think of it is you'll need a calculator if you don't have one. Yes.
Is it? Oh, yeah.
Go on, Miley. Alright.
What you doing?
Wait, don't you have
I've got to clear it. I've got to reset.
everybody reset it.
11.
Alright, it's calculating time. We're going to remember to hit reset because we don't know what someone's done with these. We then go 11 sine 35. So you should all have something that looks similar to that. Drum roll, please. Good job, Nathaniel. 6.3.
I got 8.
Did you hit reset?
Oh, no.
That could be the issue.
Congratulations.
6.3. So it's 6.3 kilometers. How many decimal places do you need to go, guys? As many as you want. You can do 1, you could do 2, you could do 3, you could do 0. Do you have to round up or round down?
Down.
It's whatever you decide to do, but if you're going to round, state how many decimal places. Alright, any questions? Alright, I'm going to do one more, but I'm going to go on fast forward. This is going to go. B. A random triangle suddenly appeared. It's a bit strange because this angle is up here. It's a right angle here. We know this is 37 meters, and we know that this one over here is y. What we want to do is we want to calculate the value of y. First thing we always do when we're calculating the unknown side length in a triangle is we look for what? Miley, we look for the right angle here. After locating the right angle, we draw an arrow at, and what side do we find? The hypotenuse. Excellent. Now, once we've discovered where the hypotenuse is, we turn our attention to the angle. The side length that is opposite the angle of interest is called what, Claire? It's called the opposite. Excellent. You're on fire today. And then, Chanel, bring it home. What do we call the final side? Not the opposite, the adjacent. Excellent. So we have 3 quantities. Do we need all 3? No. We most certainly do not. So we get rid of the one that neither has an unknown marking or a measurement. No need for that. Next step, we state what we have. We always start with theta. Theta in this case is equal to 25 degrees. We have our adjacent.
Muscular adjacent.
We have our hypotenuse. I always choose to write the hypotenuse last. We now need to think what ratio would be good here. So, ka, or ta. Cos. It's cos because we have an A and an H. And there's always a C in front if it's AH. Next, let's do the calculation. We're going to write cos theta is equal to the adjacent over the hypotenuse. We substitute our values in. Theta is 25 degrees. The adjacent is y. The hypotenuse is 37. Now, we want to know the value of y. Who's hanging out with y? Well, the current boundary to getting to y is at 37 on the bottom. 37 on the bottom means y divided by 37. How do we reverse the divide by 37? We times by 37. Is it always this way? Only today. Next, this becomes y because the 37's cancel. 37 goes out front, cos 25. Why did the 37 go out front? Just cos.
33.5.
Next, flip it around. Then reach for your calculator. If it's the first time reaching for your calculator today, press the reset button. If it's not the first time, that's okay. If you lent it to a friend, reach the reset button.
I already pressed it.
Press it again, just in case.
If you let your friend touch your calculator, press the reset button.
That means you have to
Because
press
in year 9, I messed with my friend's calculator and he failed the test.
it. That's his fault,
It was his fault. He should have known better.
because he didn't raise it.
But the teacher got cranky because he had to go back and remark it.
Remark it or redo it?
Remark it. We set it to radian, so all of his answers were wrong. Okay, so in this instance, the value for y is 33.5. Now, I'm pretty certain that that's correct. The answer or question is why? Well, think about it. What is the longest side in any right-angled triangle? Hypotenuse. Is it less than the hypotenuse? It is. If it's more than the hypotenuse, it's probably a mistake. Are we okay with this, guys?
Yeah.
Is there anything that I didn't explain clearly enough or we need more detail on? Okay. Questions for today. We'll start off 5 minutes on these getting set up and getting in the swing, then we'll have a break. But question 1, it is just the rearranging part. I'd recommend doing all of these. I know it takes a little bit of time, but you want to familiarize yourself with rearranging a trig equation. You're going to do this so frequently. After that, we have question 2. Label the triangle, pick your trig equation, solve for the unknown. Expectations for today, guys, is that you would complete question 1 and question 2 in full. Question 2 has 9 questions, question 1 has 6. Yeah. Tomorrow we'll work on the worded ones together. Are we okay?